primary and secondary cells. When we talk about primary and secondary cells, they are cells of different functionality. Primary cells are simply cells that delivers current in one irreversible direction. That is to say, once their power is gone, they cannot be recharged. And examples of primary cells are DANIELL cell and the Electrochemical cell. Secondary cells, on the other hand, produces current such that once the power is exhausted, it can be recharged. And examples of secondary cells are the lead acid accumulator and the alkaline accumulator. So these are examples of secondary cells. Now let's look at applications of the primary cells, which are also electrochemical cells. And when we talk about these primary cells, we have said the Electrochemical cell and the DANIELL cell are examples. Now the Electrochemical cell has two types, is of two types, the wet and the dry cell, but we shall place more emphasis on the dry cell. The dry Electrochemical cell simply consists of a zinc casing with a central rod, carbon central rod, which acts as the cathode, while the zinc casing acts as the anode. Inside this casing is the electrolyte, which is ammonium chloride. Ammonium chloride not in solution form, but in its jelly-like form, or we may say paste. And mixed with this is manganese 4 oxide, which surrounds the carbon rod, that's the carbon electrode. The manganese 4 oxide simply acts as a depolarizer, which helps to depolarize the formation of hydrogen bubbles into water. So this is actually how the Electrochemical cell works. The dry cell is much better and durable, usable more than the wet cell. Also the DANIELL cell, which we shall get to see. So the Electrochemical cell, just like the other types of cells we have currently, is regarded as dry cells, and they can deliver current as high or as much as 1.5 volts to the external device. So these are all examples of dry cells, which can be used in our transistor radios or in our torches, any other device, in toy cars and etc. These are things where we can apply these dry cells. So away from the dry cell, we shall now look at the reactions that takes place at the anode and cathode, that is anodic reaction and the cathodic reaction. At the anode, the zinc is oxidized, that is to say, it loses electrons, and these electrons passes through the external circuit and does work such as lighting up of torches or bulbs, or even driving a toy car. And once this electrons does this job, it gets to the cathode, where it further reacts, and of course the ammonium ion, that is, it reacts to the ammonium chloride, and this ammonium chloride receives these electrons and of course is reduced to ammonia and liberates hydrogen, and that is why it is reduction reaction. The hydrogen gas thus produced can be removed by the presence of the manganese 4 oxide, thus preventing it from adhering to the cathode. Otherwise, if it adheres to the cathode, after some time it reduces the current that is being supplied by the battery. The EMF of the Electrochemical cell, like we said before, is 1.5 volts. Now, because the Electrochemical cell, like other dry cells, is a primary cell, the functionality does not last too long, because as it works over time, the hydrogen bubbles, the rate at which hydrogen bubbles is being produced becomes more than the rate at which it is being oxidized. Hence, the shelf life of this cell is short, and like we said, it cannot be recharged and its strength dies off. So that is the Electrochemical cell. The Electrochemical cell works in similar function with the DANIELL cell. But in the DANIELL cell, the depolarizer here is different and the electrolyte is also different. The electrolyte is dilute sulfuric acid or zinc tetraoxosulfate 6, while the depolarizer is copper sulfate solution. The vessel here is copper vessel, and of course the cathode is zinc rod dipped in the electrolyte, which is dilute sulfuric acid or the zinc tetraoxosulfate 6. So this is a prototype of the DANIELL cell, and it works in the same way with the Leclerc cell. Now, having seen these two types of primary cells, we shall be looking at the defects of primary cells. Primary cells have two main defects. They are polarization and local action. Polarization and local action. What is polarization? When we talk about polarization, it's simply a defect that arises as a result of the release of hydrogen bubbles, that is the hydrogen gas. And this hydrogen gas surrounds the copper electrode. That is to say, surrounding the copper electrode makes the function of this cell to reduce. And these hydrogen bubbles are being released when zinc comes in contact with sulfuric acid, which is the electrolyte. To take care of polarization, normally the zinc rod should be cleaned or brushed. That is one main remedy of taking care of polarization. The other method of taking care of polarization is by the use of the depolarizer, which oxidizes the hydrogen to water and thus removes the hydrogen bubbles around the carbon electrode. If the hydrogen bubbles keep accumulating around the carbon electrode, it will set up a back EMF, which thus reduces the current that is being supplied. So this is the defect called polarization. Local action, on the other hand, is as a result of the wearing away of zinc electrode, which is due to the presence of impurities present in the zinc rod. Impurities like carbon and iron. Now, how can local action be taken care of? It can be taken care of by first cleaning the zinc rod with sulfuric acid H2SO4 and then rubbing the zinc with mercury. That is to say, the zinc is being coated with mercury. This coating with mercury is otherwise called amalgamation. So it forms a mercury zinc amalgam. Once this amalgam is formed, it covers up the impurities in the zinc and prevents them from coming into contact with the electrolyte. So this is actually how to take care of local action, which is one of the defects of a primary cell. The dry Leclerc cell can take care of the polarization effect to some extent. But as we said before, it comes to a point where the production of hydrogen becomes more than the oxidation by manganese 4 oxide, and hence polarization is not totally taken away. So these are the defects of primary cells. So next we take a look at the secondary cells, and we shall be discussing the lead accumulator. The lead accumulator is made of the sulfuric acid as its electrolyte, dilute sulfuric acid as its electrolyte, and it is commonly applied as car battery with an anode of metallic lead and a cathode of lead 4 oxide. When this cell is connected to external circuits, it delivers electricity by the process of discharge. That is to say, it discharges its inbuilt or stored energy. And as this takes place, it actually brings about different reactions at the anode and at the cathode respectively. Now we shall take a look at the anodic and cathodic reactions. At the anode, the lead atoms from the metallic lead gives off 2 electrons, thus becoming lead-2 ions, which goes into the electrolyte, meeting with sulfate 6 ion of the electrolyte to form lead tetraoxosulfate 6, which eventually gets deposited on the anode. The electrons flows through the system and can be used for starting up the engine of the car, and also for lighting the headlamp of the car, and for other devices that are electrical devices. These electrons flows through and gets to the cathode, where lead-4 oxide and hydrogen ion from the electrolyte receives the electrons and are reduced to lead-2 ion and water respectively. The lead-2 ion further reacts with sulfate 6 ion in the electrolyte to form lead tetraoxosulfate 6, which gets deposited on the cathode also. The voltage of the lead accumulator is 12 volts, and as it works, its density reduces to about 1.15 gram per cm cube, while the EMF of the cell also decreases to about 1.8 volts from 2.2 volts. As a lead acid accumulator works, it comes to a point where it stops discharging when all its inbuilt energy are exhausted. Hence, to continue the discharge, it has to be recharged, and recharging the accumulator battery is by the process of electrolysis. So this is how the accumulator battery works. And with this, we come to the conclusion of everything about cells or electrochemical cells. But before we end the class formally, I therefore leave you with the following homeworks, which will keep you busy and of course keep you going. And further still, we have selected questions from our WAEC syllabus, which are very, very helpful, as I believe you going through them will make you to become stronger. Peradventure, you also may have questions. Please do not hesitate, dear students, to forward your questions to us, as I will be waiting eagerly to receive your questions and attend to them adequately. You may also wish to go into more studies. I will expose you to further reference materials which could help you for your study, your personal study, and your guide. I do hope therefore to see you in our subsequent videos, and I hope you stay cool and calm. Thank you, and do have a nice day.